Right, we're ready to resume after lunch, so I'm going to make contact with Miss Grange to ensure that she's there. Hello, Miss Grange.
Hello, Mr. Chairman. Can you hear me?
Yes, thank you, and I take it you can hear and see us.
Yes, very clearly.
Good, thank you. And now we'll check that Mr. Mahoney is there.
Yes, Mr. Chairman, I'm here.
Hello, Mr. Mahoney. Good to see you, and you can see us, I hope, and hear us.
I can indeed.
Thank you very much. Well, then, if you're ready, we'll ask Miss Grange to carry on.
Okay.
When you're ready, Miss Grange.
Yes, thank you. Yes, Mr. Mahoney, before we broke for lunch, you were pointing out that there was a Max Fordham document, their smoke ventilation analysis revision A of May 2014, which in your view is an important document in terms of switching to this Betterment approach, which you were referring to. Is that correct?
Yes.
Yes, let's have a look at that. It's EXO 50892.
That changed on the 13th of May, I think it was. So there's a change a week later.
Yes, we know there's a revision B as well, but I just want to kind of understand what you're saying about the significance of this document generally. I think if we look at page 2 of it, that's the front page, we can see that it says under summary, this report has been prepared in order to compare the design performance of the existing smoke extract ventilation system in Grenfell Tower with the design performance of the new system proposed as part of the refurbishment works.
Yes.
It's been found that the proposed upgrade to the system should result in a considerable performance increase. Existing system 1.1 to 1.2 meters cubed per second, and the proposed system 5 meters cubed per second. Yes?
Yep.
Now, had you provided the figure of 5 meters cubed per second in that? No. That was their figure.
Yes.
And I think we'll see it in a moment, but this first revision, certainly, they were still looking at the push-pull system as their proposed system, in contrast.
That's correct by the wording, but incorrect in their proposal. I spoke to them about it. They got their proposal wrong.
I see. Okay. But is the thrust of what you're saying that when you received this as part of your package of documents,
Mm-hmm.
your understanding was that the objective had now moved from providing a compliant system to providing a system which was merely better than that 1.1 to 1.2 meters cubed per second across the stair door. Is that correct?
That is correct, because you couldn't put a compliant system in.
Right. So that was why you thought this document was significant, because you were just merely now comparing with the volume of air across the stair door that the existing system was assessed to be able to produce, yes?
Yeah, we were issued with this document as part of a tender package.
Yes, I understand.
To become part of the contract.
Yes, okay. And just to make good the point that this version of it, certainly if you look at page 5, does appear to be suggesting that it's the push-pull system that they're comparing. We can see that in the last part of that paragraph. It talks about push-pull in the first line, and then at the end it says this principle is to be retained but automated in the proposed new system.
Yeah.
So is that the error that you said you drew attention to?
That's correct. I think that paragraph drops out in the next one. Even though there's still wording in the document, this is misleading. That particular paragraph, I believe, drops out.
I see. And just to be clear, even though you thought you were now simply looking at this Betterment route,
Mm-hmm.
I think you said before, and I just want to check, you still felt that the proposals you were putting forward were compliant with the functional objectives of the building regulations, yes?
Yes, B1 and B5, yes. But in a different way to the normal compliance systems, because we couldn't put them in.
I understand. Let's look now. We were going through your second statement and how you describe the system in your second statement in contrast to your first statement. Can we go to your second statement again at paragraph 41 on page 8? So at 40, you said that you did not design it to comply with all the requirements of that British standard on pressure differential systems. And then you say this at 41.
Yeah.
My design reflected a more common type of mechanical extract depressurization system, a performance-based building-appropriate solution widely adopted as a type of smoke control system and which were often referred to within the industry as depressurization systems, and is commonly called the Colt shaft mechanical shaft system. Yes?
That's correct.
So this was, just to be clear, a performance-based building appropriate solution. Yes?
I don't know whether you can use the word appropriate, but yes.
Well, it's your...
It's an alternative.
Right, those are your words. But by performance-based, I take it there were some performance criteria for it.
Oh, by the designer, yes.
Yes. And can you recall ever saying what you've said in that paragraph, including the fact that it's a system which is commonly called the Colt shaft mechanical shaft system? Did you ever discuss that with building control?
No, I did not. And the reason I put it in there is valid. And that is that when I read the transcript of the smoke control experts' evidence to the panel in phase 1, they were asked the question, I can't remember the precise wording, of is it possible a system that was installed was to give an equivalence to a BR 79204 system or a Colt shaft system? And the answer given by the expert was they weren't familiar with those system types, therefore they couldn't answer and give any comment on it. All shaft systems are based on those two sort of system types, whether they be natural or powered. So I was somewhat taken aback that the expert, given evidence to the panel, didn't know that. So that's the reason that's been put in there, to say, hey, you really need to look at this.
Right. That's not quite what you say there, though. Is it your evidence that this system was one that's similar to the Colt shaft mechanical shaft system?
It reflects it. It's not the same. We cannot put a compliance system in. That would have been a compliance system. It was impossible to put a compliance system in, but it would have given the same performance as that system, but not by following the SCA guide, for example.
I see. Were the principles that it applied similar to the Colt shaft system?
The extraction rate's the same.
I see. And again, why wasn't that communicated to building control at the time, if that was part of the design intent?
Because the building control at that time were aware of Betterment. They had agreed it and signed it off. So they were only looking for a system that delivered the cubic meters per second as in the Max Foden document.
So is what you're saying that one route that building control had suggested was comparing the performance of the old system with the performance of the new system and checking that the performance was better? Is that what you're referring to there?
Indeed, yes.
Now, I'll come on to ask you some more questions about the Smoke Control Association guidance in due course. Mm-hmm. But Mr. Hansen says in his witness statement for the transcript, that's paragraph 52 of his first statement, that the system was designed in accordance with the principles of the SCA Guide 2012. Now, is he right about that?
Principles, yeah, it delivered the same ventilation rate. That's the principle. We could not put it in accordance with the recommendations in that guide.
I see. What about following other recommendations in that guide, for example, about setting performance criteria and objectives and documenting the design process? Was the system meant to be designed in accordance with the process set out in the SCA guide?
No, because we couldn't follow it.
Why couldn't you follow it?
Because we couldn't put that type of system in.
I see. Now, just moving forward with the chronology, we know that you left PSB at the end of February 2016, and you were on gardening leave in February 2016, and then you began working for Colt in March 2016. Is that right?
Correct.
And our understanding is that David Harrison of PSB took charge of liaising with JS Wright. Is that your understanding?
He was already doing that. He was the project manager for the project in advance of that date.
Yes. And we can see that you were involved with version 5 of the technical submission. We have emails that show that you were still involved with that. Mm-hmm. Then there's a final revision, was revision 6, dated the 15th of March 2016. And that has David Harrison's initials on it. To
Yes.
what extent were you consulted about the final 6th revision to that technical submission?
I wasn't consulted.
You weren't?
No.
But I think we can agree that the key paragraphs in that technical submission setting out the design intention and the key performance requirements remained unchanged, didn't they, throughout?
As I understand it, yes.
Yeah. Now, I now want to ask you some more detailed questions about the final design of the system. And I want to start by looking at some diagrams that Dr. Lane presented in phase 1 of her investigations. If we go to BLAS 5038 at page 2. Now, just to be clear, I'm going to show you a series of similar diagrams like this.
Mm-hmm.
Now, this first diagram is showing a depressurization arrangement if the flat was depressurized rather than the lobby.
Yes.
So, can you see that? We see here that they've depressurized the flat and therefore smoke and heat is prevented from spreading out through an open door because it's at a lower pressure. So there'd be an airflow into the flat from the lobby. Yes?
That's what it implies, but it wouldn't work in reality. But go on, yes.
I know, I understand. I'm not sure, Dr. Lane, I don't think she's suggesting that. I think she's just, in a very simple terms, looking at how depressurization systems might work in principle in different parts of the building. So then if we go to page 3 of this clip, the next page.
Before we move on, that would not work in principle. It simply would not work.
Yes, and normally when you do a depressurization system like this, you do it for, say, a basement, don't you, which is entirely enclosed, yes, where you can depressurize the space.
A basement would be a smoke clearance system.
Okay, but it's one of the pressure differential systems that's mentioned in the British Standard 12106, isn't it?
That is correct, and it would not work in a block of flats, yes.
No, I understand that, and I'm not sure Dr. Lane's not suggesting it would work, but we're just exploring the principles.
No, but it's important that the lay people listening to this understand that what you're showing there will not work. Okay. I don't know. I therefore don't understand the purpose of putting it in.
Well, you might see in a moment.
That's your call. But there you go.
Mr. Mahoney, perhaps you better tell us why it wouldn't work. Then we'll all know.
Because you cannot create a vacuum when you're sucking air out of a space, as in the fire flat. You must have an airflow path in the flat. Okay, so when the door is closed before the fire brigade arrive, that system is supposed to operate. It will not operate because there's no airflow path.
Right. Thank you very much.
I understand. Now, if we go to the next diagram 3, this is the Grenfell smoke ventilation system in very simple terms. Mm-hmm. So air is extracted in the yellow arrows from the lobby.
Yeah.
Air is pulled through the open stair door and the lift shaft at 2 meters per second. Mm-hmm. And the flat fire door is assumed not to be open. Is that correct? Yeah. So the basis for the design is that there's an open stair door, but not an open flat door. Yes?
Yes. There's a but there, but go on, yes.
Okay. Do you want to say what the but is? You might as well say now.
If that fire flat door was then to open, we would still protect the stair by the volumetric flow rate from the lobby.
Yes, well, we're coming on to that. Let's look at the next diagram.
Right.
What Dr. Lane's showing here is that if the stair door and the flat door is open, there is the potential for smoke to be pulled from the fire flat through the open flat door and into the lobby. Now, do you accept that there is that potential for that to happen?
No. At that stage, because there's no makeup air into the flat, you're not going to pull it out. However, the smoke would flow quite naturally out at high level because it's hot, assuming it's a hot fire, and cold air would come from the lobby underneath that smoke flow coming out through the same doorway into the flat, therefore feeding the fire, and smoke would flow out naturally, not pulled out by the system. So no, I totally disagree.
Right, I see. But what if there were windows open in the fire flat?
With the windows open then the smoke would flow more freely from the flat into the lobby.
Yes. Well, at Grenfell Tower, we know, for example, that flat 16, the kitchen window was open on the night of the fire. It was a hot June night.
Yeah.
So in those circumstances where you've got windows open, not necessarily broken in a fire, but just open,
Yeah.
is there the potential for smoke to be drawn from that flat into the lobby?
Not drawn, no. It will be forced out by its own energy. But as I said previously, it still won't enter the stair because of the volumetric flow rate.
Do you not accept that because the lobby is at a lower pressure, that there would be this potential for air to flow from the flat into the lobby?
Of course it would, because the fire is the high pressure zone. The fire will create its own pressure head.
Right.
So it will flow out naturally, whether that door up to the stair is open or not, it will flow out. So the purpose of the system is to stop it getting into the stair.
Well, that's why I've been asking you, and I've asked you twice, I think, already. Is that right? Is the purpose of the system merely to stop it getting into the stair, or is the intention of the system to provide some protection to the lobby? And I think you said this morning that it would, and it was designed to provide some protection to the lobby. Is that correct?
Right. Let's go back a few steps, because you're conflating two things quite wrongly. If we take what the guidance documents tell us that we have to do, is that fire is occurring in that flat as drawn, but all the doors are closed. Okay? Then the occupants of the flat will make their escape, and some, not loads, not masses, some smoke may travel with them. That's what the code says. All right? At that moment in time, there is no ventilation at all in that lobby, none whatsoever. Then if sufficient smoke enters the lobby and triggers the smoke detector, then the system will then start to operate and go into its operational mode. Okay, so until there's enough smoke, there's no ventilation. Then you get, if the door then closes, it should behind those people, there will be low-level ventilation, B1. And that low-level ventilation is created by the minus 25 PA. Okay, it'll be pulling air in from around cracks of all doors, the lift shafts, the stair door, all doors. Okay, and that will equate to somewhere in a region about 1 cubic metre a second. Then once the stair door then is open, the system will ramp up to the full speed and extract from the lobby at 3 cubic metres a second.
Yes.
So there's a sequence of events. This is a snapshot in time, which therefore is totally out of context.
And can I just ask, you're assuming that once the occupants have left the flat door closes, thereby preventing smoke from entering the lobby. Is that correct?
That is correct. That is part of the compartmentation rules for blocks of flats and what we're told to design for.
Yeah, thank you.
They will come out for a short period of time, the door will be open, then it will close. And if you look at the way we CFD model, that is reflected in the modelling.
Yes, I see. I'm going to come and ask you in a little while a bit more about different scenarios and what, in fact, it was reasonable to assume would occur on a fire floor like this in due course. But I just want to stick with the kind of basic point, and I want to put this to you, that aren't you effectively protecting the staircase from smoke in this system at the expense of moving more smoke out of the fire flat and into the lobby if those two doors are open at the same time?
No.
And why not?
Because the amount of smoke coming out will be the amount of smoke coming out. It has its own driving force. When the door is open, the pressure disappears. The differential disappears because the door's open.
Yes.
So there's no pressure now. So the high pressure zone is the fire zone. It will create its own pressure head subject to temperature and density changes, and it will drive the smoke out. There is no differential in the lobby at that stage.
I see. But importantly, therefore, and particularly given you've just said that, in terms of the stair protection, isn't when the door to the fire flat opens, isn't the airflow through the stair door likely to be reduced because the pressure difference will have dropped in the lobby?
Yes. However, as I said before, the volumetric flow rate from the lobby will stop that smoke flowing into the stair.
Yes, but did you ever calculate at any time as part of your design process the extent to which the airflow rate through the stair would drop if the flat door was opened at the same time as the stair door?
No, because enough modelling has taken place over the years to prove that the case of how the system operates. So no.
So you just assumed, based on your knowledge of previous modelling, that it would be adequate still to protect the stair, even though you would lose, because you would lose your 2 metres per second then, wouldn't you?
That's right. And the critical number is the 3 cubic metres a second.
Yes, but you keep saying the 3 cubic metres per second. That's the same as the 2 metres per second.
No,
You're just talking about volume, and I'm talking about speed.
It's not
so
the same.
If you lose the speed, why aren't you losing the volume as well?
Because the fans will still extract the volume.
But the fans...
It doesn't matter where it takes the air from, it takes the air from. It does not stop the fan operating at full speed, no. The fan will still operate at full speed.
Yes, but the fan's got nowhere to go once it's gone up once to full speed, has it? It can't go up again.
Doesn't need to.
You don't think it needs to?
It doesn't need to, no.
Well,
So
I'm sorry, can we make sure we understand why Mr. Mahoney is saying what he's saying? Mr. Mahoney, you objected when council suggested that you would lose the 3 metres a second when the stair door was open.
Where would you lose it to? It's still taking 3 cubic metres a second out of the lobby. And that will stop the smoke coming from that flat flowing into the stair.
But if you've lost your 2 metres per second speed of air through that door, aren't you also losing volume? Isn't it a corollary of that?
Let me go back a few steps. If we put a fully compliant system in, it would work exactly as we're discussing, a compliant system, a mechanical shaft system. It extracts 3 cubic metres a second, and when that stair door is open, it will have 2 metres a second. Once the fire door opens, you've still got 3 cubic metres a second on a standard system, and it stops the smoke going into the stair. We know this. Okay? That's what we know in our industry.
So sorry to keep interrupting you, but I think what you're telling us, Mr. Mahoney, is this, that the fans will extract the 3 or 3.5 cubic metres a second, even though the opening of the stair door will affect the airflow rate in. Is that right?
That's right. What you have to remember is, at this moment in time, looking at that diagram, there's no broken window. Okay? So the smoke will come out under its own pressure head. Okay? It will flow. Cold air will flow in underneath that hot layer coming out, and there'll be a transfer between the two spaces. It won't be huge, and you're still taking your 3 cubic meters a second out, and the bulk of the airflow is coming from the stair. If a window breaks, you have a new airflow path. But air will always take the least line of resistance to flow. Okay? And the system will still fulfill its function, because the amount of air that you can pull through a doorway is the amount of air you can pull through a doorway. It will be split between the two once a window breaks. Before the window breaks, you can't create a vacuum in the space. So you can't suck out of the space because there's no air coming back in.
I see.
But as I pointed out, some air will go in, because it'll do that by the natural heat transfer that's going on between the hot smoke being driven out and cold air being driven into the burn process. The fire acts like a pump, pulls cold air in and pushes hot smoke out. So the transfer will be dictated to by no window being open and a window being open.
Yes, I see. So I think what you're saying is, once there is a potential airflow route through the fire flat, then you're accepting that the position might be different and you might lose your
velocity, but not the volume flow. The volume flow remains constant.
Yes, but you lose your velocity through the stairs.
That's right. But as I've said before, we're happy with the amount of modelling that's been done, that smoke still would not enter the stair.
I appreciate you're happy with that, but can you explain why that was never calculated specific to Grenfell Tower? Why no one ever did a calculation to say, once the flat door's open and there's some kind of airflow path, whether that's an open window, a broken window through that fire flat, what the effect would be on your 2 meters per second and how much would be lost?
The standard is accepted as a standard. You don't do calculations.
Well, when
you can even buy this kit off the shelf. It's standard.
When you say the standard is accepted as a standard,
let Mr. Mahoney finish his answer. Then
you
come back.
There are certain manufacturers of these systems where you can buy the components as a kit off the shelf, because the answer is the answer. So you don't have to calculate anything because the answer is known. You don't do a calculation. The 3 cubic meters a second is almost throughout the industry a universal number that's used because we know through research and our own modelling that it works. You don't redo the calculation every time. It is the answer. If it was a commercial building with large undivided volume spaces, it'd be a different answer because you've got a larger fire load. The fire load is dictated to by the compartmentation.
Yes. Now, you say the standard is the standard, but, and I'll come on to this in due course, if you were looking at a system that was designed to the British Standard 12101 Part 6,
you cannot design a system to that standard to work.
Yes, but
sorry.
Can I finish?
I was going to say, Mr. Mahoney, let counsel finish her question and then she'll let you finish your answer.
Right.
If you were designing it to that standard, then the standard forces you to confront what would happen to your airflow if different combinations of doors are open, doesn't it?
I think there's another conflation going on here.
Well, maybe let's come back to this because
let me think of what you just said. Right. So, if you have certain numbers of doors open, certain doors open have no material effect on the ventilation rate. For example, the fire brigade would arrive at the fire entry point and they open doors, so there's a door open there. You then travel to the firefighting lift to the floor below the actual floor that's on fire, and the lift door then opens. They come out of the lift, they then connect their hose to a dry riser main.
Sorry, Mr. Mahoney, I'm going to interrupt you, and we'll come on to this in due course.
So generally, the doors being open have no effect, no.
Right. So you're saying that different combinations of doors being open has no effect on the airflow across the stair?
For a pressure differential system or my system?
Well, with a pressure differential system, it does, doesn't it?
No.
I see.
The critical thing with a pressure differential, looking at your sketch now, let's reverse it round. You're blowing air into the stair, you're blowing air into the lift, and you're blowing air into the lobby, and then the windows could be open, but in this arrangement, you couldn't use windows. You'd have to put a purpose-made shaft in behind the front door to the flat. The air would flow from the stair into the lobby, out of the lobby, into the flat, and out of that shaft. It doesn't matter what other doors are open, other than the ground access level door, because air bleeds to outside in that application, because it's pressurized positively. Okay?
Right. We'll come back to that, and I'm going to ask you some more questions about that later. Let's just focus now for a moment on the Colt shaft system, because you say, as we've seen in your witness statement, that this system is similar to the commonly called Colt shaft mechanical shaft system. Now, to what extent did you actually rely upon any analysis of the Colt shaft system when you were developing your design for Grenfell Tower?
I did not. As I told you, I put that in there because the experts didn't know what they were talking about.
I see. So it wasn't something that you took into account at the time that this was similar to the Colt shaft system?
Well, the reason I put the words Colt shaft in there, the systems are commonly called. I'm sure that's the wording I used. I didn't say it is. They're commonly called Colt shaft systems because Colt were the market leaders in that industry using those type of systems, and it becomes synonymous with their name.
Well, you tell us, let's go back to paragraph 41 of your second statement, page 8. You say, my design reflected a more common type of mechanical extract depressurization system.
Yep.
You tell us that it reflected that, and that system was a performance-based building appropriate solution. And then you go on to say, and it's commonly called the Colt shaft mechanical shaft
It's
system.
commonly called, yeah.
Yeah, so that's why I'm asking, to what extent did you draw upon the Colt shaft system when you were designing the system at Grenfell Tower?
Well, let me try and explain it a different way then. When I say commonly called, it doesn't mean Colt shaft is the reference point. It's a mechanical shaft system, but the industry knows it commonly as a Colt shaft system. But it's a mechanical shaft system.
As in the system you installed at Grenfell Tower, is that?
No, it can't be because we can't follow the recommendations. It has the same outcome as that. But it can't be put in the same way, which I'm sure we'll come on to. So
did your design reflect a system that is commonly called the Colt shaft mechanical system?
It reflects the outcome of it, yes.
Right. Now, in her phase 2 report, Dr. Lane has explained that to aid her understanding of that Colt shaft system, she has considered 2 Colt technical papers. There's a technical paper from 2004 called Mechanical Ventilation of Firefighting Shafts, Performance and Design, and a paper from 2007 called CFD Analysis of Smoke Ventilation in a Firefighting Lobby with a 12 megawatt unsprinkled fire. Now, can you recall, had you read those Colt documents when you specified when you designed the Grenfell system?
No, but I would question the validity of the second document referred to. Why a 12 megawatt fire in an unsprinkled building? It's not relevant to residential buildings.
Fine. Well, let's look at the 2004 technical paper. Were you aware that technical paper, and I'll take you to it, but in general terms, were you aware that paper expressed concern about the extract tending to draw excess smoke into a lobby through gaps around the closed door to the accommodation, to the flat?
Yes, that's why you use minus 25 PA to stop that or to mitigate it.
So if we go to BLA 405484, this is the paper, and I want to look at page 3. It's that paragraph that's got the yellow highlighting in it. It says in this paper, while the door open condition is the most critical, the system, of course, has to deal with conditions with the lobby doors closed as well. An obvious concern was whether the mechanical extract would tend to draw excess smoke into the lobby through gaps around the closed door to the accommodation. Do you see that there?
Yes.
And if you look at page 4, sorry.
Carry on reading. Don't stop there because you're taking something out of context again. This condition was therefore also modelled with the addition of a pressure relief damper in the shaft to limit lobby depressurization to 25 PA. The model took a worst case condition of a double door. Okay. So that's consideration of the 25 PA pressure differential.
Is that where you got your 25 PA pressure differential from?
I didn't take it from that document, no.
Right. And if you look on page 4 under 3.2, we can see this is for a mechanically ventilated shaft, and some of the figures have had to be redacted with a door open condition. For this particular configuration, you can see it says at the end paragraph, the overall extract flow rate is greater than provided by the BRE shaft. The results show, however, that this increase is not beneficial. The system draws more smoke out from the accommodation and makes conditions worse in the lobby with a deeper smoke layer and higher temperatures.
Right.
See that?
Yeah.
And then at page 5, under discussion, the paper says this, we can see in the yellow highlighted paragraph, it is important that the mechanically ventilated shaft is not overrated, since an increase in the design extract rate tends to draw excess smoke from the accommodation into the lobby, making conditions in the lobby worse.
Yeah.
Now, were you aware that the 2004 paper modelled this condition with the addition of a pressure relief damper in the shaft to limit the lobby depressurization to 25 pascals to alleviate this tendency to suck smoke into the lobby from the fire flat?
I wasn't familiar with that paper at that time.
Was the potential effect of drawing smoke into the lobby from the fire flat something you ever considered?
Yes, that's why we designed for minus 25 PA.
I see.
And not forgetting when you're extracting at minus 25 PA, you're sucking air through and around all doors, not just the fire flat. So the amount that would come from the fire flat is reduced by the amount you can draw from other doors. So it's not all coming from that one door.
Yes.
So the ventilation in the lobby at the minus 25 PA will reflect the amount of air that can be drawn in around the crackage, around all doors, including lifts.
I see. Now, can we agree that the Colt shaft system, in comparison to the system that you designed, is materially different, including in the physical arrangement of the components and their performance specification?
No. Pat, no.
No, you don't think it is different?
We're not necessarily using the same components, are we? Because we're a different company. But certainly the ventilation rate is the same.
Okay. If we can look at BLARP 2, 5035 at 161. I'm looking for table 5.8. I think it might possibly be the next page. Yes, so in this table 5.8, what Dr. Lane has done is compare the Colt shaft system with the PSB technical proposal. And she's identified certain differences between the two systems. Now, for example, I just want to put to you, if you see three rows up from the bottom, there's a heading floor area of lobby. And you can see that for the Colt shaft system, the floor area was 12.5 meters squared, and it was rectangular, 2.5 meters by 5 meters, as per the BRE report. Whereas the floor area of the lobby at Grenfell Tower, you can see on the right-hand side, was 32 meters squared, and it was an irregular I shape with dead-end corridors to flat entrances. Do you see that?
I'm not sure I can. There's so much information on that screen. Where are we?
Sorry. We are 3 lines up from the bottom, three rows up from the bottom. On the left-hand side, there's a label floor area of lobby. Do you see that?
3 lines up.
Three boxes up.
Rows up. Three boxes up.
Right. Now, where are we?
3 boxes up from the bottom on the left-hand side. You should see some words.
No, sorry. Floor area of lobby, right? I'm with you.
Yeah. And in the Colt system, the floor area was 12.5 meters squared, and it was a rectangular shape.
Mm-hmm.
At Grenfell Tower, she's then put the configuration of the lobby on the right-hand side, and you can see it was 32 meters squared, and it was an irregular I shape with dead-end corridors to flat entrances.
Right.
Now, doesn't this show us that the Colt system, or the Colt system, was a very different type of system from the one you installed at Grenfell Tower, in that there were Grenfell-specific features of the building that made it different from the systems that had been modelled by Colt?
The layout is different, but the volume of smoke entering the lobby won't be different.
I see. Why don't we see any consideration in your design documentation of the potential dead zones and the I shape of the lobby and the impact that that might have on this system?
Because it's not relevant. I don't know where this dead end thing, this is the second time you've asked this question, that the systems are not designed to deal with dead end sections of that nature. Even the compliance systems don't do that.
Are you aware that Colt supply what's called an extended corridor system designed to complement the Colt shaft system, where there are extended travel distances in a common corridor?
Answered this morning, yes.
And Colt recommends using something called an extended corridor system, not the Colt shaft system.
Yeah, the push-pull.
There are those increased travel distances, yes?
Yeah, push-pull, yeah, which we've already discussed and said we couldn't do.
So were you aware of that Colt extended corridor system at the time you were working on the Grenfell Tower project?
Is it relevant to Colt? I was aware of those system types from the SEA guide.
Why wasn't that more appropriate, or the more appropriate Colt comparator, given the extended travel distances in the Grenfell Tower lobbies?
If it's impossible to install something, it's impossible. So you cannot do it. Therefore, what am I supposed to say? You could not do it. You couldn't put that system in.
And just to be clear, why are you saying you couldn't put something in that was like an extended corridor system?
Well, to start with, it certainly wouldn't have dealt with what you just said about dead end bits, because I've explained this morning, it's dealing with a straight corridor section where the air flows from one end to the other. It doesn't flow around corners and then back out again. It simply would bypass it. So it doesn't deal with that. With regard to other aspects of this, the system type, because of the constraints of the employer's requirements, you'd have had the high velocity jetting from the low level grills. And in my opinion, that would have pushed smoke into the stair.
I see.
So you couldn't use that type of system because we couldn't get the air to enter into that space at the right velocity.
Right. Now, in your second statement, you refer to the Local Authority Building Control, the LABC certificate for the Colt shaft system. Can we just go to that certificate? It's INQ 3014683. I want to look at page 2. Under scope of registration in this LABC certificate, we can see that it says, this registered detail relates to Colt shaft, the mechanical ventilation, means of escape, firefighting systems, etc. And then if we pick it up in the third line, it says Colt shaft means of escape systems, other than the standard shaft approach, will be justified by project-specific CFD analysis. All systems are subject to performance testing and commissioning at project completion. Were you aware that the LABC certificate provided that systems other than the standard Colt shaft approach were required to be justified by a project-specific CFD analysis?
How do I answer that question? The answer is no, because it's not required, but I am aware that it's recommended that if you have extended travel distances, that you would CFD model it, but it's not required. It's not mandatory.
So you are aware that it's recommended that if you have extended travel distances that you would CFD model it, yes?
I would myself recommend it CFD modelled, yes.
Why didn't you recommend a CFD model at Grenfell Tower, given we've agreed that there were extended travel distances?
Because we already know that the system couldn't comply with the requirement for extended travel distances. We could not install a system to do that. So you don't CFD something that's going to fail.
But couldn't you CFD something to see how it performs?
Right. If you're going to CFD something, normal practice is someone says, we need to CFD model this. Here's an order, we'll pay you for doing the modelling. So no, unless you're being paid to do the modelling, you don't do it until such time that you're requested to do it. It's not something, these things take a long time to do. They can take up, depending on how busy your CFD modelling company is, it can take anywhere between 2 and 10 weeks to do a model of this nature.
Yes, but what I'm seeking to get to the bottom of is why not recommend some CFD modelling on the Grenfell Tower project?
This was discussed with Max Fordham and partners. There was insufficient time to carry out modelling. So modelling was not considered, and that was also a requirement of why the decision to go down the Betterment route. There wasn't time to get any approval for a non-standard system.
Sorry, if you can just wait for the end of my question each time. So when you say this,
I'm eager to get corrected.
This was discussed with Max Fordham and there was insufficient time to carry out modelling. When did you discuss that with Max Fordham?
In our second telephone conversation, when we went through the problem with trying to put a compliant system in, and then the subject of CFD model was brought up by Max Fordham, and then we responded by saying how long it would take, and the fact we would need an order to proceed with that work.
Why didn't you recommend that there should be CFD modelling to check that the system could work in the way you thought it might?
Why didn't we recommend it?
Yeah.
We discussed it and it was agreed there was no time to do it. So there's no point in recommending it if they're not going to do it.
Just finally on this Colt shaft point, and we saw that you raised it in your second witness statement, are you aware that the Colt shaft system was primarily designed as a system for commercial premises, office accommodation?
Which system are you talking about? They got more than one, and one is for residential apartment buildings.
So if we can pull up a witness statement now, COL 701. And if we can look at paragraph 1.7 on page 2. So he's talking about the shaft system described in the reports. Those are the two BRE reports that I mentioned earlier, which are referred to in the LABC certificate. It says the shaft system described in the reports is a mechanical firefighting shaft smoke ventilation system originally designed and intended for buildings over 18 metres in height, constructed primarily for office use. The two documents in question were prepared to be specifically relevant for commercial projects. Fire sizes and construction layouts differ significantly for residential applications, and neither reports were originally relevant to them. And then if we go on at page 3, at 1.8, he then says, while applicable to commercial buildings, the 2004 Colt report has been used as the basis for designing smoke control systems in residential stairs, but only after publication in 2005 of a second BRE study on behalf of the then OPDM, now MHCLG, which concluded that suitably designed mechanical ventilation can provide protection to the stairs, that is, in principle, resilient to adverse wind and building stack effect pressures. This can be achieved by either depressurizing the corridor lobby relative to the adjoining stair. However, as the 2004 report was written before the second BRE report, it does not make reference to the use of these systems in residential buildings, and the 2007 report was only ever intended to support unsprinkled office applications. And then he says further, in many cases where Colt were contracted to a project where the building design incorporated any non-standard conditions, for example, non-compliant travel distances to approved document B, smaller shafts or unusual shaft locations, project-specific modelling and a project-specific report would have been prepared. And then at 2, he says, 2.0 below that, says, as the 2007 report is specifically only applicable for unsprinkled offices, it therefore has no relevance to Grenfell. Do you see that there?
I do indeed.
And can we agree, therefore, that the original Colt system was developed for commercial office accommodation?
Of course it was. That's where they talked about a 12 megawatt fire, which you wouldn't get in a residential building.
And that subsequently, although it's been by other studies extended into residential systems, Colt have said that where they are contracted to a project where, for example, there are non-compliant travel distances, smaller shafts or unusual shaft locations, project-specific modelling and a project-specific report would have been prepared. Do you see that? I
do, and I said I totally agree with that earlier.
Why don't we see project-specific modelling and a project-specific report for Grenfell Tower?
Because we've had the discussion with Max Vodham and it was decided not to do that. I can't make people spend their money and make me do a model.
I see. But how strongly did you recommend that project-specific modelling and project-specific report ought to be prepared?
It didn't become necessary because they went forward on a betterment.
I see. So because you say you were just merely trying to better the airflow rate of the old system, it didn't become necessary to do any form of modelling?
That wasn't my call. I was offering advice.
I see.
That wasn't my decision to make.
Just moving on then, can we go to look at something in BSEN 121016? We've referred to this British standard a number of times, and if we could look at it, RBK 3045054. And I want to look at section 9 on page 57. This is at the bottom of the page. You can see it states here under general, the objective of a depressurization system is to achieve the same protection at the doorway between the depressurized space, e.g. a basement, and the protected space, e.g. a stairwell, as would be achieved by pressurizing the protected space. It is important to note that there's no protection of any part of an escape route within the depressurized space itself, which may be entirely filled with smoke or may even be fully involved in a fire. This constitutes a fundamental difference between depressurization and smoke exhaust ventilation. To be effective, each depressurized space shall be bounded on all sides by fire-resisting constructions, because any loss of integrity would result in an equalization of pressure between the depressurization zone and external air. However, in compartmented buildings, it may be possible to depressurize individual spaces. Now, would you agree that this section of that British standard is therefore explaining clearly that with a depressurization system, there is no smoke protection for the depressurized space itself?
In a large undivided volume space, yes. That's where the fire is. That's where the fire is. However, in compartmented buildings, it may be possible too. And this is a compartmented building we're talking about, not a large undivided basement.
But in the case of Grenfell Tower, doesn't that mean that although the system was designed to prevent smoke-filled air going into the stair, it was not providing smoke protection to the lobbies?
No, it doesn't mean that at all. I've already explained. If you look at 2.25 of ADB, it's very specific in what he wants the system to do, and it was designed to do that. You're conflating that again with a space that's on fire and full of smoke. That's not B1. If the place is in the fire and full of smoke, you won't get B1.
Can we also look at BS 9991 2011? That's at BSI 50621. There it is. We saw it earlier on this morning. And I want to look at clause 26.1 of this on page 66. This is the heading smoke control for means of escape. And under the heading general, it says, in residential buildings designed with a stay put strategy, additional protection to the staircase should be provided in the form of a smoke control system. And then you can see the commentary underneath. It says, whilst the primary aim of smoke control in residential buildings is to protect the staircase enclosure, it can also provide some protection to the adjacent protected corridor or lobby. And then it says this, in extended corridors, the primary objective of the smoke control system is to protect both the common corridor and the staircase enclosure for means of escape. Do you see that there?
I do indeed.
Now, we know that Grenfell Tower did have extended travel distances, both as defined in approved document B and in this BS 9991, i.e. over 7.5 metres. Yes?
Yes.
Do you agree that as a result, according to this guidance, a smoke control system needed to be designed to protect both the staircase and the common corridor, i.e. the lobby?
I totally agree. However, you couldn't put that system in. It was impossible. So I agree, but with that qualification.
So you did appreciate that at the time?
I totally understand that. I've been involved in drawing these standards up. So yes, I totally understand it and I totally subscribe to it. But if you can't do something, you can't do it.
Why don't we see a clear statement in the design documentation then saying, even though that is what's said in the British standards, and even though we have extended travel distances here, this is why we're not protecting the lobbies? Why don't we see any grappling with this in the design documentation? Because
it was discounted when we had our discussions of advice with Max Fordham and partners, and we therefore were not involved in that decision-making process of where it went from there. We merely followed on from what they then agreed with building control. So you wouldn't see anything anywhere because it was never done.
I appreciate it was never done, but why?
The reason why it was never done, because at that moment in time, we were told they were not going down the design route, they would go down the betterment route.
Yes, but even
and
with
that's what happened in the contract documents.
Yes, but even with the betterment route and trying to make the system better than the old one, wasn't it nevertheless important to grapple with the fact that Grenfell Tower contained extended travel distances and therefore there needed to be some protection to the lobby?
You couldn't give it, so you couldn't do it. And it was discussed.
If we can go to clause 0.2.3 of this document on page 11, we can see it says smoke controlling common parts there. And if we look in the second paragraph, it says smoke can be controlled in the common areas through fitted ventilation systems, which are either natural or mechanical. These ventilation systems have two main purposes, the first of which is to provide some protection to the stair core, and the second of which is to aid firefighters when tackling a fire. Ventilation systems can also be used to compensate for extended travel distances within the common corridor leading to the stairs, and thereby help occupants to escape safely. Where smoke control is used to provide compensation for extended travel distances, it is the responsibility of the designers to demonstrate that the ventilation system can provide tenable conditions for the occupants using the route with extended travel distances. Now, just to be clear, I think what you're saying is you didn't ever consider the impact of extended travel distances in your design. Is that right?
We couldn't. We couldn't put a system in that would deal with it.
So you didn't attempt to demonstrate how the system could provide tenable conditions for using the lobby escape route. Is that right?
I don't understand what you're trying to say in that question. I don't understand it. If you can't do something, you can't do it.
So I think we agree there's no consideration of whether the system could provide tenable conditions in the lobbies for those using the lobbies as an escape route, is there?
I'm not sure how to answer the question. I really don't. I'm lost. If you can't do it, you can't do it.
Annex E of this document.
Ms. Grange, do you want to put it to Mr. Mahoney as to what he should have done? Perhaps he'd understand the question a little better.
Yes, what I'm putting to you is that the design documentation should have recorded the fact that there were extended travel distances. Do you agree?
Right. If the design documentation should contain that, that was for the design engineers and the fire engineers to do, not the smoke control engineer. That was not the case. It did not happen. So that when we were asked to look at it, we told them and advised them we couldn't put anything in that formed any form of compliance. Therefore, took a different view, the designers, to go down a different route.
I see. So I think you're saying that it was not for you to consider the effect of extended travel distances in the lobby.
I did consider it and I pointed it out.
Can I just intervene again? I think there's a danger of getting at slightly cross purposes here. Mr. Mahoney has said in the past that that PSB were not designing a system, although your question rather assumed that they were.
Yes.
Well, is that right, Mr. Mahoney? Were you designing a system?
We started off by designing a system, yes. But then that quickly was rejected because we couldn't convince the designers to put a non-compliant system in because it was non-compliant, using my language. We couldn't get it to comply with any guidance or standards. However, using engineering judgment, it was a reasonable approach to try and do it in a different way. They then said they didn't have time to go down a route of trying to get a non-compliant system approved or CFD model, so they went down a route of Betterment.
And are you telling us that the Betterment route, as you've described it, was not one which involved any design on your part or the part of PSB?
They just used the volumetric flow rate that we gave them.
Yeah. All right. Thank you very much. Yes, Ms. Gray.
Yes. Yes. I mean, I think to the extent that you are suggesting, Mr. Mahoney, that you didn't do any design,
No. As I said earlier, I'll put my hands up there. I did do design. I did look at this and offered the best solution that was available given all the restrictions.
Yes.
We did discuss all of these points, including we couldn't put a system in that would comply. Therefore, we offered an alternative design solution. That alternative design solution was not taken forward by the designers. They went forward on Betterment.
Well, just to be clear, what are you saying? Are you saying your alternative design solution was the one where the smoke was extracted up both the shafts?
That's correct, which didn't comply.
Which did comply, you're saying?
Didn't comply.
Didn't comply.
I'm sure we'll come to that when we get to the SCA guidance or any of the documents you want to go through, BS 9911. It did not comply with the suggested formation of a system within those documents.
Yes. I understand. But then I think you confirmed earlier that you then modified the design so that it was extracting down through the south shaft, and you didn't indicate that there was a problem with that design, did you?
That wasn't my situation to question it. They had agreed a betterment, and that was part of what they were doing.
But just going back to this betterment, even with betterment, are you saying that when you're simply trying to better the old system, are you saying that you don't need to think about extended travel distances as part of that approach?
No, don't put words in my mouth. That's not what I'm saying at all. I told you I had considered it, but there was nothing I could do about it with the constraints that were given by the employer's requirements. If you can't do something, you can't do it. So it was then discussed with the responsible party, because we weren't the responsible party, we were merely offering advice, and it wasn't taken, what we suggested wasn't taken up because they didn't believe they would have sufficient time to get a non-compliant system approved. It did not comply. It didn't give you those aspects of design that you're talking about with regard to safe travel distance.
Yes. And one of the things I'm seeking to understand is if you did consider it as part of your betterment approach, you did consider the extended travel distances, why don't we see that consideration written down in any of your design submissions, in the technical submission or any other proposals? Why don't we see it recorded that there were extended travel distances and an explanation or a mitigation provided as to why that was nevertheless acceptable?
Because what we were suggesting wasn't accepted. We didn't go beyond that point. We were not involved in this contract. We were not a party to all these conversations, all this documentation flow that was going on. We had a single conversation which followed up with a single email that said, this is what we want you to do. We went back against that and said, we can't do anything. The best we can do is this. And that was then rejected. Then we fell out, as in we were no longer involved. Until such time, the tender documents arrived when we were asked to tender against those documents. And that document then existed, which said, we're going forward on a betterment.
And Mr. Mahoney, in that context, the betterment context, who, if anyone, did you think ought to have been considering extended travel distances?
You couldn't consider them.
Right.
Oh, sorry, correction. You could not put a system in that complied with current thoughts and smoke control methods to deal with that because of the constraints imposed by the employer's requirements.
Yep. Thank you.
If we can look at the SCA guidance now, I want to look at the 2015 version of that guidance at RBK 402932, page 6.
Can I ask why we're looking at this document that doesn't refer to this particular project?
Is that because of the timing of it?
Because of the timing of it, yes.
Yeah.
The contracts in a contractual status, the documents that are relevant are those that were published and used at the date of planning permission.
Well, I appreciate that's your position, Mr.
That's not my position, that's a contractual position.
Well, Mr. Mahoney, let's just see what Council wants to ask you. And in due course, the panel will decide what is relevant to what. But we'd like your help if you're prepared to give it to us on some of these other points. So off you go, Ms. Grange.
Thank you. Yes, and we do know that Building Control did send this version of this SCA guidance to the professionals involved in the project during the course of the design process. So it's not wholly irrelevant. If we can look at this at page 6, under 2.1 primary objectives, in the second paragraph, it says, where the travel distances are no more than 7.5 metres in distance from the door to the staircase or sterile lobby to the most remote apartment entrance door, the primary objective of smoke control in residential buildings is to protect the staircase enclosure by ensuring that the stairways remain relatively free from smoke and heat in the event of a fire within a dwelling. And then if we look 2 paragraphs down from that, it then goes on. However, where corridors are extended, the primary objective of the smoke control system is to protect both the common corridor and the staircase enclosure. There are considered to be 2 forms of extended corridors. And then the first form, extended corridors, it says, These typically have no more than 15 metres travel distance from the furthest apartment door to the staircase or sterile lobby. The primary objectives of the smoke control system are to protect the common corridor for means of escape and the staircase enclosure for means of escape and firefighting. Do you see that there?
I do.
And were you familiar with this part of the SCA guidance while you were working on the Grenfell project?
I was indeed, and I can also point out this for extended corridors, not lobbies. It's quite specific in what they're talking to you about.
So you are saying, are you, that where it talks about corridors being extended, that doesn't apply to a lobby, yes?
No, I'm saying what that applies to.
I see. So are you saying
because later in the document, the system type will be the system type that flows in at one end of a corridor and out at the other, not an awkward shaped lobby.
But isn't the thrust of this guidance that where the travel distances are more than 7.5 metres, you need to treat the primary objective of the system as to protect both the common corridor and the staircase enclosure?
The common corridor, yeah, I totally agree. Common corridor, not the common lobby.
But whether it's...
No, you cannot you cannot do what you're trying to make this fit. It doesn't fit. If you've got a straight corridor or an L-shaped corridor, you can make it work. You can't make an I-shape work on extended travel distance. It's simply not possible.
So are you saying that if you looked at this guidance, you don't have to treat the lobby and the stairs as the primary objectives, because this is referring just to the common corridor? Is that what you're saying?
That's not what I'm saying. What I'm saying to you is if you read the complete document, not isolated parts, you will see that when it comes to how you deal with an extended corridor, it is a corridor. It's a straight tube or an L-shaped tube. It is not funny shaped lobbies. So the objective is the objective. This, taken out of context, doesn't mean what you're saying it means.
I see. So when you've got an extended travel distance but an irregular shaped lobby...
It needs careful consideration.
Yes.
Yes.
You accept that?
I accept that. I've said all along through this conversation, yes, I accept that.
If we also look at paragraph 5, section 5.1 of this guide, it states at the bottom, if we look at the bottom of page 11, this is about objectives and performance criteria. It states here, it's the second from paragraph from the bottom, it's the responsibility of the assessing engineer to determine which method of investigation should be used. Sorry, let's read one paragraph before that. As with any alternative solution, there are a number of methods which allow the investigation and demonstration of its performance. These range from hand calculations through to more sophisticated computer models such as zone models and CFD. Each method often offers different benefits with associated limitations, ranging from fast calculations with limited spatial and temporal resolution to extensive spatial and temporal resolution with extended calculation time. It is the responsibility of the assessing engineer to determine which method of investigation should be used. It is recommended, however, that the technique to be used be agreed with the relevant approving authorities prior to an assessment being performed. Do you see that?
Yes.
Now, did you understand that those paragraphs applied in terms of the guidance they're giving about investigation and demonstration of performance to your work at Grenfell Tower?
As I said before, what we suggested wasn't accepted.
Well, what you ultimately suggested was accepted because version 6 of PSB's technical submission is in fact the design for Grenfell Tower, isn't it?
I don't know. I wasn't there at the time.
Well, you can take it from me that version 6, and we know you worked on everything up to version 5, and I think you've already accepted there weren't any fundamental changes. That version was the system that was installed at Grenfell Tower and which was accepted by building control.
Yes, and that system was designed to deliver the 3 cubic meters a second from the document that was produced by Max Fordham.
Yes, can you explain why we don't see a determination of what method of investigation you're going to use to assess and demonstrate performance and we don't see that being agreed with the relevant approving authorities prior to that assessment being performed.
It was already signed off at that stage. This document had gone in from Max Fordham, as I understand it, and I might be proved wrong, is my understanding, and that it was signed off by building control on that betterment. It was already agreed before we become party to the contract.
Yeah. Can we look at a figure from Dr. Lane's report? If we go to BLARP 2, 5035, at page 73. What Dr. Lane's done in this flowchart is attempt to summarise the processes and the assessment methodology that's recommended in both the 2012 and the 2015 SCA guide. Mm-hmm. So what you've got at the top is questions to be asked, whether there's a demonstration of system performance required. Yes. Is the building design fully compliant with ADB? No. Establish what type of system it is, then define the assessment methodology, and then it splits into deterministic and comparative methodologies. Deterministic involves setting design criteria, conditions and performance criteria to be determined on a case-by-case basis. Comparative is the more traditional route and involves proving equivalence to one of the prescriptive systems in ADB after setting design conditions. And then there's lots of stages that the SCA guide recommends. And what the SCA guide starts off by saying is that it's acceptable to have alternative solutions to those set out in ADB, provided you follow this kind of methodical design process. Do you see that?
Yes.
Now, can you explain why we don't see anything like this in any of the design documentation that was prepared by PSB, even though you are someone who is intimately familiar with the 2012 and the 2015 SCA guide?
Because we weren't responsible for putting the design forward to building control. That was done by others.
So are you suggesting that somebody else should have gone through this step-by-step process?
No, I'm not suggesting that at all. That's not for me to suggest. What I'm saying to you is we didn't put the design document forward for approval to building control. That was done by others, and it was done on a betterment basis, which normally would not cover any of these. That's my understanding.
I see. So is your understanding that where you're just doing this betterment approach, even though that's an alternative system, not a system that's set out in any British standard or other guidance, that you don't need to follow a logical step-by-step approach as part of the design process?
Not on an existing building which is being refurbished, no. If it's gone down a betterment route, that's all you need to do. And I'm sure that building control would have asked for a lot more information if they felt it wasn't a betterment route. And they signed off on that basis. So
we go back to your point that because you thought all you were doing was bettering the flow rate of the old system, you didn't need to provide any of this documentation relevant to your design.
I was following the requirements of a contract. The documents that are issued, and I'm sure you're aware when you have a contract, you have express terms and you have implied terms. The implied terms of Acts of Parliament, etc., that you do know about, such as the Health and Safety at Work Act, but the express terms are written down, and that's what you follow as part of the contractual agreements that you reach. And that was a document of betterment that said we have to design a system that delivered 3 cubic meters a second. That's all.
I see. Mr. Chairman, I think that's a good moment.
Yes, we'll have a break. I think that would be a good idea. Mr. Mahoney, we'll have a bit of a break now. We'll stop and resume at 25 to 4, please. And again, as before, please don't talk to anyone about your evidence while you're away from the monitor. All right?
Okay.
Thank you very much. See you at 25 to 4.
Okay, thank you.
Thank you very much. Thank you, Ms. Grange. 25 to 4.
Thank you.
All right, well, we're now ready to resume. So, well, there's Mr. Mahoney, first up. Hello, Mr. Mahoney. You're obviously ready to continue.
Thank you very much.
Well done. I better check Miss Grange is there as well. Miss Grange, you there?
Yes, I am.
Oh, hello. Good. Right. Well, Mr. Mahoney is already logged in, so to speak. So when you're ready, thank you.
Yes, thank you. Yes, now this morning we looked at part of your witness statement where you explained that the services that PSB provided were provided pursuant to a number of purchase orders by JS Wright. Can we just look at one of those purchase orders at JSW 403835? We can see that this is from JS Wright. The contract is for Grenfell Tower refurbishment, and under subcontract order details, it says design only for AOV system, unit price £9,450. Do you see that there?
I do.
And was that the purchase order for PSB providing the design, but design only, not installation, but design of the smoke control system?
Not in the sense I think you mean, no.
What do you mean by that?
That when we take on a project and we get an order to do it, what we're looking to do is extend the known design into a complete working system. So the design involves the preparation of cause and effect statements, drawings, technical submission, and all those aspects in support of the design requirements.
I see. So what you're saying is the design requirements were set before you did your detailed design work. Is that right?
That's correct. As I can't remember, I think it's item 2 of our technical submission tells you what the base documents were, one of which was that Betterment document. So what we were then setting out is how we would put our system in to meet that Betterment document.
Do you accept that you were contracted to do and carry out the detailed design of the smoke control system pursuant to the employer's requirements documents you were provided with by Max Fordham?
What documents are they?
Well, the ones you've talked about that were referred to in your technical submission.
All right, the drawing and the Betterment.
Well, what you're calling the Betterment document.
Yes, that's right, yes.
And just to be absolutely clear, if we look at your second witness statement, page 14, paragraph 74, you say, conclusions, for the reasons outlined above, I believe the basis of my design and the performance criteria I specified for the system were sufficient to meet the requirements of the building regulations. Does that remain your evidence?
It does.
Thank you. Now, if we could look at an email, PSB 50725 at page 9. So beginning with the 16th of July 2015 email from Mr. David Bradbury to you that we see there. In his email, Mr. Bradbury sends on to you a series of questions from Matt Cross-Smith of Max Fordham. We can see those questions below at page 10. And is it right that the answers in red were your answers that you provided? Yes?
That's correct.
And looking at page 10, in answer to the first query about the low level point of smoke discharge, you address that specific point, and you also say, picking it up in the second line down in red, this system will not be extracting smoke during the evacuation phase, as air will be drawn through the open stairwell door and it will pull in clean air from the stairwell. During firefighting operations, air will again be pulled in from the stairwell. Should a window in the fire-affected flat break, then some smoke may be extracted during firefighting operations, i.e. the flat door is open and the stairwell door is open.
That's correct.
Now, we've discussed that earlier, and that's consistent with what you were telling us earlier. But can you just explain the answer to this? Why don't we see the scenarios that you're discussing here, for example, flat door open, window open in the flat. Why don't we see any of those discussed and set out in the design documentation and an explanation provided about what the system was and wasn't designed to do?
In my documents?
Yes, your documents. You're answering this question here and you're providing this scenario and you're explaining what would happen in this scenario. Why don't we see a discussion like that in any of your design documents?
My document was to show confirmation with the contract document. So therefore, there was no need for me to write all this up. The fact it will occur is the fact it will occur.
And when you say my documents was to show confirmation with the contract document, are you trying to say that somehow your contract limited you so that you couldn't actually consider the design scenarios the system was intended to address?
We merely had to comply with a delivery system to do 3 cubic meters a second. Oh, sorry, 3.5.
Yes, I see. Now, just back for a moment to the point about, sticking with this point about scenarios, I just want to show you something in the British Standard EN 12101 Part 6. If we go to RBK 45054 and look at page 20, now this is the airflow criterion for a Class B pressure differential system according to this British Standard. And I understand you didn't design it to comply with all of these criterion, but what I want to look at is what this British Standard would require. And what it says is that the air supply under airflow criterion shall be sufficient to maintain a minimum airflow of 2 meters per second through the open door between the lobby and the accommodation at the fire affected story, with all of the following doors open between. So the doors are the stair and the lobby on the fire affected story, the stair and the lobby on an adjacent story, the firefighting lift shaft and the lobby on the adjacent story, the stair and the external air at the fire service access level, and the air release path on the fire floor is open. So the British Standard, if you had designed a system that had complied with this British Standard, and I appreciate you say you couldn't have done, but it requires that 2 meters per second to be maintained despite lots of other combinations of doors being open. And so can we agree that that's what the British Standard does? That's what the British Standard says, yes. And Dr. Lane, in her report, has explained, if we look at BLARP 2, 5035 at page 396, at paragraph 8.11.33, she's set out the criterion from that British Standard that we just looked at, and she said this: the open doors listed above are intended to replicate firefighting operations in a non-residential building where the fire and rescue service use the floor below the fire floor as a bridgehead when they exit from the firefighting lift and attach a hose to the fire main on that floor. In a non-residential building, yeah? Yeah. The fire and rescue service then run a hose through the door to the firefighting stair on the floor below the fire, then back through the door to the lobby on the fire affected door, and finally to the door of the flat. Mm-hmm. Now, do you agree that to be an appropriate system for installation at Grenfell Tower, the system needed to show that it could operate effectively with this arrangement of doors open? In a residential building rather than a non-residential building? Because that's about non-residential buildings. But do you agree at Grenfell Tower that you needed to be able to show that it could operate effectively with this arrangement of doors open? It would have done. Didn't need to show it because they have no material effect on the door where the air is being extracted through. And again, are you saying that that's simply based on your past experience that you knew it would have done? Of these systems, yes. In his evidence to the inquiry last week, Mr. Hanson, the building control officer, said that his expectation was that PSB would be testing with other doors open and closed in accordance with this British standard for a Class B system. Was that your expectation as well, that you would be testing the system with different combinations of doors open and closed?
Yes and no. In the end analysis, if I go back to your previous question, the reason why they're critical is because you're blowing air in, not sucking air out. When it comes to the system that we put in was sucking out, those doors being open would have no material effect on the airflow through the doorway from the stairwell into the fire-affected lobby. If anything, it'd be given an enhancement because it give more air coming in.
So are you saying there are no circumstances in which other doors being open would affect the airflow through the stair door?
No, because if the apartment door is open, that would have an effect. But those doors, no.
What about if another apartment door was opened and that, for example, had a pathway to the outside? Wouldn't that potentially affect the airflow through the stair?
The pathway to the outside be created. We're suddenly talking about a scenario where doors that should be closed are now open. But they should be closed. We said earlier, compartmentation is the primary function of controlling a fire and spread of smoke in a building, not the smoke pressurization or smoke extract system. It is the compartmentation. So if a door is open that shouldn't be open, no, we can't account for that.
Would you agree that not only the British standard, but also, for example, the 2012 SCA guide provides recommendations about the need to consider different opening doors when designing the system, because any such system needs to address the foreseeable scenarios which will occur when the system is operating?
They're talking about the doors on the escape route, not random flats.
But you do accept that the SCA guide requires consideration of other open doors when designing a mechanical smoke ventilation system?
Yes, and as I said, they would have no material effect on the system.
In section 12 of her phase 2 report, Dr. Lane has concluded that she cannot identify any time period in the early stages of the Grenfell Tower fire where only the stair door was open as per the system's design condition. Doesn't that indicate that one single stair door being open and all other doors being closed was an unrealistic design assumption to make?
Not a design assumption, it's a given. It's given in the ADB. It says in there that you will get some smoke coming out when the people make that escape. For that short period of time when the door is open, some smoke will come out. Not that the door is open and the smoke is pouring out. No, that is given to us. And that's what we design for. That's what all design is designed for. It's not unique to Grenfell Tower. To suggest so is wrong.
Well, I've put the point to you that her evidence is that it was unrealistic to think that just one single door would be open in a fire scenario. And therefore, the design should have provided for different door opening conditions and grappled with those conditions as part of the design process.
And she needs to write a bit of standards and the approved document be a governing body and get them to change the documents.
I see. Can we turn to compartmentation now, a different topic? Do you agree that where smoke control systems are comprised of shafts and ductwork penetrating internal compartmentation, their construction is also subject to the functional requirement B3, internal fire spread?
That's fire engineering. I don't tend to get involved with that.
Were you aware that the shafts and ductwork which connected the lobbies as part of the smoke control system at Grenfell Tower would be classified as a protected shaft and must be protected to limit fire and smoke spread between compartments?
That's a given because that's fire engineering.
So you were aware of it, but you say that wasn't part of your role?
Of it because we don't get involved in building. We're not construction experts.
And it's right, isn't it, that at Grenfell Tower, the builder's works shaft and subsequent extension of those shafts during the primary refurbishment connected every lobby compartment in Grenfell Tower from ground level to level 23?
Yes.
And can we agree that the horizontal metal ductwork at level 2 of Grenfell Tower, the new ductwork for the system, was also connected to the south shafts and hence also became part of the protected shaft as well?
I believe so, yes.
And were you aware that in approved document B, it makes clear that any system of mechanical ventilation should be designed to ensure that in a fire, the ductwork doesn't assist in transferring fire and smoke through the building and put at risk the protected means of escape from the accommodation areas?
I am.
To what extent were those considerations uppermost in your mind when you were designing the system at Grenfell Tower?
What are we talking about?
The one I've just mentioned, that any system of mechanical ventilation should be designed to ensure that the ductwork doesn't exist in transferring fire and smoke through the building. Was that a consideration that you paid attention to when you were designing the system?
Yeah, we discussed this with Matt about the connections in the rooftop plant room to connect the north and south shaft together to form one system would be in fire-rated ductwork. Because it was in an unused plant room, it wouldn't be necessary to insulate it. So it'd be fire-rated.
Now, let's focus on dampers for a moment, installed as part of the smoke control system. Let's just have a look at some useful images of those. If we can look at Dr. Lane's smoke control report, BLARP 25035 at page 181. There we can see they're the north dampers, and if we go over the page, we can see there the north dampers on level 4. So on the right-hand side, we can see the grill that was in front of the dampers, and then on the right-hand side, it's not a brilliant photo, we can see some of the dampers themselves. Do you agree?
I agree.
And if we look at BLARP 25037 at page 34, we can see in one of the storyboards that Dr. Lane has produced in her report perhaps some better photos there. You can see on the left-hand side, say at level 6, you can see some of the dampers open at level 6. Can you see that?
Yes.
And there's a useful little sketch above that that's taken, I think, from Professor Steck's report, where you can actually see the dampers themselves in those sketches.
Right.
And can we agree that it is critical that those dampers are up to the task, not only of opening and closing when required, but also delivering a high level of performance in preventing smoke permeating them while they're closed?
Yes, I agree.
And can we agree that in the standards, in the British standards and other guidance documents, dampers are divided into 3 categories: fire dampers, fire and smoke dampers, and then smoke control dampers? Were you aware of that?
I'm aware of that.
And can you explain in simple terms what the difference is between them?
A fire damper is one which has a thermal device which allows the damper to close and has a given fire resistance, so that if it gets up to a certain temperature, it will automatically shut. A fire and smoke damper, again, is one that controls smoke and fire, i.e., in the final analysis, if the temperature gets too great, the fire damper side of it will dominate and shut the ventilator. And a smoke control damper is one that is a high seal damper for controlling the flow of smoke in mechanical systems generally.
Yes. So the smoke control damper is the highest level of performance of damper, isn't it?
Yes.
Now, as the lobby damper's protected an escape route, if we look at BSEN 12106 part 6, if we can pull this up at RBK 3045054 at page 71. And if we look at clause 11.8.2.10, it's kind of just beyond halfway down that page. We can see it says there, if different pressurized or depressurized zones are connected to the same fan or set of fans by a common system of ductwork and or shafts, smoke control dampers shall be used. Do you see that?
See that? We weren't working with this document, but yeah, I can see that.
Were you aware of this guidance at the time you designed the Grenfell system?
I was.
And it's right, isn't it, that smoke control dampers have to satisfy more onerous testing requirements than fire dampers or fire and smoke dampers?
I agree. However, these were not smoke dampers. They were automatic opening ventilators. But I know where we're going to go, but go on. But they're not a damper in their own right.
I see. Well, let's keep going. do you agree that the permitted leakage limit for smoke control dampers is stricter than for fire dampers? The leakage rate has to be less than 200 meters cubed per meter squared per hour, according to the relevant British standards.
I thought it was no greater than 200.
Yeah.
Not less than.
I see. Yeah. Now, it's right, isn't it, that PSB's design documentation did not specify that the system had to use smoke-controlled dampers, meeting the prescribed leakage requirements for smoke-controlled dampers. Can you just explain why that was?
Why we didn't specify them?
Yes.
Because there were no dampers on the market at that time that could be used, that were smoke control dampers.
I see. So you're saying that because that product wasn't, so what, there were no products on the market at that time that had been tested to those more onerous requirements?
No, what I'm saying is those dampers that were available could not be fitted into Grenfell Tower. Do you want me to clarify that?
Yes, please.
Yes, I think we need to understand why you didn't use smoke control dampers at Grenfell Tower.
All smoke control dampers at that time, and I think most to this date actually, but at that time, none had been tested for use in walls. They had only been tested for use in ducts, and the manner in which they are secured is part of the test requirement. So we had, on our working groups at SCA, we had actually experts from the Manufacturing Association as members of that working group. And they advised us that you could not use those dampers in a wall because they weren't tested to be used in that way. Right? So they were not certified for that particular application. Another reason was the size of the framing of the damper would have made the hole materially smaller, exacerbating our problems of trying to get the system to deliver the volume flow rates. And the third reason was smoke control dampers have a spindle that pokes out of the side of the damper construction to which a motor is fitted. Therefore, that would have clashed with the wall. It would not have gone into the opening. So we couldn't use those products.
I see. If we look to your first version note of the technical submission for the smoke control system, this is at PSB 50207 at page 6. We can see this is in the technical specification that you wrote.
Yes.
That you've actually selected Gilbert's 54 series dampers.
Yes, so my automatic lobby ventilators, yeah.
For use in this application. So you yourself selected those products for use in this system, yes?
It indeed.
What information or documents did you have about those dampers before specifying them in this version of the technical submission?
At the sales brochures.
Yes. Now, we can see that you had access to the October 2011 Gilbert's product brochure for Series 54 dampers, as you attached it to an email of the 13th of November 2014 to David Bradbury when sending version 0 of the technical submission. That's at PSB 50207. Now, if we look at that product brochure, it's at PSB 50201. There's the product brochure. And if we can look at the second page of this, if we blow up the text at the top in the introduction, there it says, in the second paragraph, a multi-parallel linked blade smoke damper. The Series 54 is manufactured from robust 1.5mm galvanized steel and is fully tested to the requirements of EN 1366 Part 2 for 1 hour. Now, did you notice when you looked at that product brochure that it was saying it was fully tested to those requirements for 1 hour?
Yes.
And what impact did that have on your decision to specify these dampers?
The fact that it gave me the 1 hour fire resistance I was looking for was good. It was a low leakage damper and it actually fitted the hole in the wall.
If we go then to the quotation for these dampers that was provided by Gilbert's, that's at PSB 401240. Now, in his evidence to the inquiry, Mr. Jones of Gilbert's, who we're going to hear from later this week, says that you contacted Gilbert's for a quote in relation to dampers, first speaking to Mark Griffiths at Gilbert's over the telephone. Is that correct?
I don't recall, but yes.
And then on the 22nd of January 2015, you can see at the top that date, that Mr. Griffiths provides you with a written quote for the dampers in this written quote. And we can see your name. The contact is Hugh Mahoney, I beg your pardon, in that quotation.
That's okay.
Thank you. So this is the quote. Do you remember, does this help jog your memory? Do you remember receiving this quotation?
I honestly don't, but yes, I would have received it. And before you ask, yes, I would have read it.
Thank you. And if we look at page 2 of this quotation, there are some additional notes. After the item descriptions, there are some additional notes. And I want to look at item 3 under that. It says this: the Series 54 damper is designed to be used for natural and mechanical smoke extract applications by means of a vertical shaft. The damper has undergone an EN 1366 Part 2 test, started from the closed position and lasted over 60 minutes for both fire integrity and smoke leakage, ES60, but has no formal certification. Now, did you note that that information differed from what the 2011 product brochure said about the dampers testing?
I didn't take cognizance of it then, but I can see what you're saying in that it was tested from the closed position, whereas the other document says it was tested fully in accordance with.
Exactly. And also, this says it's got no formal certification. Did you notice that at the time?
I was aware of that because of, do you mind if I explain how I'm aware of it?
No, but go ahead.
CE marking was coming in under the products regulations that were Act of Parliament. I spoke to quite a number of damper manufacturers, including the people on the committees that we were working with, or working groups. And a lot of the damper manufacturers were saying that they were not going to test to the latest standards, and therefore they were not CE marking their products in accordance with the latest standards. However, they were prepared to market them under the old standards and CE mark to them, which made life very difficult for the likes of us in the smoke control industry, because we couldn't then comply with an Act of Parliament. And the Series 54 was one of those dampers where they had no intention of testing to the BSEN 12108-8 standard. And in actual fact, no one at that time was testing to that standard.
I see. But do you accept that there was an explicit statement here from Mr. Griffiths to you in this quotation that the product was not certified to BSEN 1366 Part 2, which is the key test for fire dampers and fire and smoke dampers, yes?
It doesn't actually say that. It says no formal certification. It was tested, and if it was fully tested to BSEN 1366 Part 2, it would have failed the test. The reason for that is a test for a fire damper. A fire damper has a thermal device, and the first part of the test is to test with it commencing in the open position, and then you ignite the furnace, and you then record how long it takes for that damper to close from the open to the fully closed position. Yes. On a thermal device going off. Well, these dampers do not have thermal devices. Thus, it's tested from the closed position. It would have failed.
Yeah. Thank you. Now, if we can look at Dr. Lane's report at this point, if we go to BLARP 2, 5035, page 92. I want to look at paragraph 4.8.70. She starts that paragraph by saying, but it is important to note that the test method for evaluating both integrity, E performance, and smoke leakage performance, that's S, is different. This is as between fire dampers and smoke control dampers. The key differences are as follows. And she goes on, if we go over the page. If we can go over the page. And she says there at the top, A smoke control damper is subjected to a greater number of open-close cycles prior to testing. This is termed the durability of operational reliability. A smoke control damper intended for a combined smoke and environmental system is subjected to 10,200 open-close cycles prior to fire testing. A fire damper and fire and smoke damper is subject to just 50 open-close cycles. Do you see that?
I do.
And then she goes on, the ability of a smoke control damper to change from the open to the closed position or vice versa at elevated temperatures is tested. This is required where a system is designed with a manual intervention function, such as the Firefighter override switches. Fire dampers and fire and smoke dampers are not subjected to this tests.
Correct.
So then she says these key requirements in the test methodology when evaluating the integrity and smoke leakage performance of smoke control dampers are more onerous than the conditions applied when testing fire dampers and fire and smoke dampers. Do you see that?
I do.
Did you ever send the quote with its reference to no formal certification on to building control?
No, that wasn't my role. My role was to send it through to JS Rights. They were my employers.
So building control only saw the product literature, it would appear. Is that correct?
No, I think we got the test data and sent that through to them.
I see. Now, if we go to an email now from Gilbert's to you, if we go to GBL 705 at page 2, and I want to look at the top of page 2. Yeah. Here we can see Gilbert's are providing to you a copy of the 41-page document entitled Exova Fire Resistance Test, dated the 6th of October 2011, which we'll see in a moment begins on page 3 of this string, and a 3-page data sheet from Bellimo issued in May 2007, which begins on page 44 of the string. Now, can you recall exactly when this information was provided to you? There's no date on these emails. We haven't been able to ascertain that.
It was following our first meeting with building control. I don't know what that date was because they requested the information.
Yes, I see. And what prompted Gilbert's and Mr. Griffiths to send this information to you?
We phoned them up and said we needed this information for all onward transmission to building control because they had questioned, had the damper been tested with the motor fitted?
And did you ever ask, for example, whether the dampers were classified as fire dampers or smoke control dampers?
I knew that they weren't smoke control dampers. They were smoke exhaust dampers. They were automatic opening ventilators. I knew what they were. They were not smoke dampers.
If we go to the fire resistance test, this is at page 42 of this document. This is the penultimate page of the Exova fire resistance test. We can see that the damper was purportedly tested according to the requirements set for fire dampers.
Yes.
For example, they were subject to an integrity test of 360 meters cubed per hour. Just looking for where we see that. Yes, that's in the second line. Do you see that there?
Yep.
Now, given that the British standards required smoke control dampers, did that concern you when you saw this test evidence?
No.
Do you accept that these dampers weren't suitable as they were neither fully certified or tested smoke control dampers?
I don't agree.
Do you agree with Mr. Jones's evidence to the inquiry to the effect that
Grange,
Gilbert...
I'm sorry. I feel that answer leaves us begging for more, if I may say so. Why does Mr. Mahoney not agree with the proposition?
They're not smoke dampers. They were not purported to be smoke dampers, and they told us how they were tested. As the other products, as I've already mentioned, on the marketplace would not fit the application that we had, and we had a betterment requirement, this was the best that we could offer. And that's what we used. They were never purported to be smoke dampers.
Oh, thank you.
Did you explain that to building control? Did you say, we understand the need in the British standards to have smoke control dampers, but this is why we've provided these alternative dampers?
No, but they knew what they were getting. And if you look at the guidance they asked us to use, which was the SCA guidance, it says in there that if they want anything greater than what's in that document, which is an E30 SA unit, they have to ask for it. But I'm not passing the onus on to them anyway. It's one of the things I know I did mention at the very front end with Matt Smith when we did our original appraisal, this was the only product that would actually fit in the employer's requirements because nothing else would physically fit. So it was the only thing we could use.
So did you look around to try and find other smoke control dampers that would work for this configuration? Did you actually do that exercise?
Yes, and there weren't any. But as I say, I knew most of this anyway through my own work at working groups and my own work in trying to find out who was going to comply with the new CE regulations.
I see. And I just want to be absolutely clear what you're saying about the SCA guide. Are you saying that the 2012 SCA guide permitted you to use dampers that weren't even certified as fire dampers in this location?
No, that's not what I'm saying. What I'm saying in there, it identifies that an automatic opening ventilator, there is no test standard for it. So in such instances, they suggest it should conform to a smoke damper, not that it must, because they don't exist. It recognises the fact that these standards don't exist for the products or the way in which the products are used. So therefore, it gives you ways around trying to achieve it. Now, the first one in the heading, if my memory serves me well, is BSEN 1210-8 for smoke and heat control smoke dampers, and no one was testing to that standard at the time. Then they give the next test standard as being smoke damper tests, but none of those tested products were able to be used in the application that we needed. And then they give you the fire test standards. So there's an order of what you can use in there, or guidance of what you can use. But it also starts off by stipulating that they're automatic opening ventilators, there is no standard, and they have to have a minimum of an E30 SA rating. That's the beginning of that particular clause.
Okay, we'll come to that. We'll come to that in just a moment. Do you agree with Mr. Jones's evidence to the effect that Gilbert's was not provided with much, if any, information about the Grenfell Tower system for which they supplied the dampers?
They knew they were for an AOV system.
How could you be satisfied that the dampers that you selected wouldn't leak excessively?
They would leak as much as they leaked. They were what they were. What do you mean by excessively? Let me put some kind of perspective to that. The leakage rate is based on a 1 meter square damper, and it's a maximum permissible. If you look at the total area, they're less than 1 square meter, so they would leak less because there's less area. So it depends what you're actually implying by the statement. So I don't quite understand.
I see.
Because you would work out the actual leakage for the size of damper, which would be less than the maximum. Yes.
If I could just take you at this point to something in Dr. Lane's Phase 2 smoke control report. This is BLARP 2, 5038, page 19. This is one of a number of storyboards that Dr. Lane has put together explaining the system performance on the night of the fire. And what she's done in box B on the left-hand side is actually put some extracts from the chairman's Phase 1 report, where several residents of floors remote from level 4, where the fire started, observed smoke leaking into the lobbies through the dampers. So, for example, we can see at 116, Mr. Griffin at flat 31 whose flat entrance is to the southeast corner of the lobby, saw smoke coming from the dampers in the south shaft before he evacuated. Do you see that there?
I do indeed.
And we then have below that Miss O'Connor at 1:20, whose entrance is to the southeast corner of the lobby, adjacent to the south dampers, noticed smoke coming through those dampers when she was evacuating. Sorry, I should clarify. Miss O'Connor does not confirm if this was from the north or south side of the lobby. Now, we know that the fire started just before 1 o'clock in the morning. In fairness to you, I just wanted you to have the chance to consider this. Can you explain how that leakage, including on the south shaft, which should have been extracting downwards, occurred so early in the fire? Can you help us with that?
On the south side?
Yes. Well, certainly Mr. Griffin, that's what he's recorded as seeing.
If it was leaking from those dampers, it would mean the whole of that shaft would be full of smoke.
Yeah.
It would then build down to that level. Not sure what level it's getting actually into that shaft, if it's getting in there. And that would suggest something is open for it to fill that quickly if you're going by that timeline and spill out. But it also would indicate that the fan wasn't operating.
Yeah. Well, he's level 6. So that would be, on your hypothesis, the shaft would have to fill with an awful lot of smoke to get down to level 6, wouldn't it, by that time? Very
quickly, yeah. And it'd have to be very hot smoke as well.
So I think you've said one possibility is that the fan at the south, for the south vent, might not have been working, yes?
It could not have been working if smoke was coming out of those dampers, because if it was working, smoke can only go in, not out of a closed damper because of the negative pressure behind it. So for it to come out, it's a positive pressure is built up within that shaft, which means the whole shaft is full of smoke to come out at level 6. It has to be full. And the fan can't be working.
Yes. Can I just look at an email string? This is PSB 50881. I want to look at the top of the thread. This is going to be an email from you to David Bradbury at JS Wright on the 31st of March 2015. Relates to a query from building control about the testing of the dampers and whether they were tested with the motors attached.
Yeah.
And in your email, you explain that the dampers were tested with the motors, and you provide a copy of the BSEN 1366 Part 2 test report for the dampers.
Yep.
Now, can we take it from this email that you must have reviewed that test report to have answered these questions?
Yes.
And if we look at the test report itself at GBL 705, at page 3, did you notice that the title of the report was a fire resistance test conducted generally, spelt wrongly, but generally in accordance with BSEN 1366 Part 2, 1999 on a multi-blade damper assembly. Did you notice that?
Yeah.
And did you notice that it says on page 4 in the summary of the test specimen that at the request of the sponsor, the test was started with the damper in the closed position?
Yes.
And on page 8, it says in the introduction, says in there that at the request of the test sponsor, the damper was in the closed position at the commencement of the fire test, and therefore the test was not conducted fully in accordance with the standard.
Yeah, I've already given you that reason.
Yeah.
Yeah.
And looking at the results on page 5, did you notice that the dampers failed the smoke leakage criteria and were therefore non-compliant for that reason?
Where's that?
Smoke leakage box, second from the top, 0 minutes.
No, it didn't fail, did it? That's been filled in because it's a box on a standard test report, and that was never tested because of the manner in which they were doing the test. So that smoke leakage test is at 0 you can't have failure at 0 because it hasn't commenced.
I see. So you're saying
That's filled in.
done that test.
It wasn't that smoke leakage test was not undertaken, therefore they put 0 minutes in it.
So just to be clear, you were not looking for test evidence to BS 1366 Part 10, nor classification to BS EN 135014, which would be necessary for smoke control dampers. Is that right?
That's right. It's not a smoke control damper.
For the reasons that you've given.
That's right.
Now, you've mentioned the SCA guide. Can we just look at that SCA guide? If we go to LFB 3059241 and we look at page 36. I think this is the section you were referring to earlier at 8.2.5, where you were saying that the SCA guide makes clear that no formal product standard exists for the use of these products in this application. That's automatic opening vent, smoke control damper, used for ventilation from corridor or lobby into smoke shaft or smoke control duct, yes?
Yep.
And just to be clear, if you carry on reading that paragraph, it says, to ensure the necessary product performance is achieved, it is recommended that the AOV should be regarded as a smoke control damper and the relevant product standards should be considered. Do you see that?
I see that, yes, indeed.
So even though it says no formal product standard exists, this is recommending that the AOV should be regarded as a smoke control damper, yes?
Correct. And the next paragraph is important as well.
So that says the damper at the fire smoke source must open to allow the smoke heat to be extracted and therefore have proven ability to maintain its opening. ADB recommends that dampers on a non-fire floor should be closed and capable of performing to the equivalent of a E30SA fire door.
Yep.
Dampers tested to the standards below should satisfy this requirement.
Yep.
Dampers should be actuated, yes?
Yep.
And then if we look below that, if we look over the page, we can see there are several applicable smoke control standards, damper standards, and those are listed below, yes? And that's 12101 Part 8 and Part 10 of 1366. Those are the British standards for smoke control dampers, aren't they?
Yes.
And then below that, I think what you're referring to is that it says any damper tested as fire resisting, supported by an ad hoc operation test at elevated temperature, and using a drive open, drive door close actuator could also be acceptable. These test standards are listed below.
Yes.
Is that right? You're referring to that part of the SCA guide as well?
That is the part that the Gilberts have been tested to. The first document there, 12101-8, as I say, no one was testing their products to that test standard. So they didn't even exist as a product.
But you say that's the part that Gilberts were tested to, and we can see it's 1366 Part 2. But then it says, plus, if you keep reading along both lines, it says fire dampers plus ad hoc test report, 300 degrees and or 600 degrees for 1 hour. And the same, there's some ad hoc testing that's required, as well as testing to BSEN 1366 Part 2. Do you see that?
The ad hoc is because you couldn't test it as a fire damper, as I said before, because if you tried to test it for fire damper, it would fail because it doesn't have a thermal device. So it becomes an ad hoc test.
But even these alternative routes therefore require not just passing tests to BSEN 1366 Part 2, but then ad hoc testing. Is it your understanding that that ad hoc testing had been carried out?
As I understand it, there were two options there. One is the first at the 300 degrees heat and 600 degrees for 1 hour, or alternatively, there's the hot test, 400 to 30 test for PRN Part 10.
But is it your understanding that the Gilberts dampers had undergone that ad hoc testing?
We had that certification, that documentation which we forwarded on.
I see.
And it also goes on to say dampers tested in a closed position to BS 476 Part 20 could also be suitable.
So you don't accept that you specified the incorrect dampers for the smoke control system?
Most definitely not. And also the fact you have to work with products that are actually available. If they're not available, they're not available.
I see. Mr. Chairman, I've got probably about 5 minutes maximum of questions, but I may go slightly over 4:30. Can I carry on and then we break? Is that acceptable? I think it would be better if we can to finish with this witness today.
Yes, I'm sure. Well, let me just have a word with Mr. Mahoney. Mr. Mahoney, we normally call a halt at 4:30, but if council only has 5 or 10 minutes questions left, I'm sure you would prefer to finish your evidence today if you can do that, would you not?
I would indeed, yes.
No,
Totally
I should just warn you, though, that when council gets to the end of her questions, we have to have a short break, usually about a quarter of an hour, to enable her to check that she's not left anything out, and also to allow other people who are following the proceedings from elsewhere to suggest questions that perhaps should be put to you. So if we carry on in order to finish your evidence, we could be here until, let's say, 5 o'clock. First question, does that bother you?
No, not at all.
And the second question is, would you like a break at this point?
I think I could just manage.
All right, well, we'll carry on then.
If it's 5 minutes, I'll manage.
Right, well, we'll probably have a 5 or 10 minutes and then there'll be a break anyway. So shall we see how we go? All right.
Okay, then.
Thank you very much. Well, Ms. Grange, yes, let's carry on.
Yes, okay. I want to ask you now about the firefighters' override switches.
Yes.
We can go to a report prepared by the Metropolitan Police for Grenfell Tower, MET 3072161. And if we just look at the report first. This is a report prepared by RENA following some reconstruction and testing of Grenfell Tower smoke extraction system. And if we go to page 17, in the final paragraph at the bottom, sorry, can we go one page on? Maybe it's, no, that seems to be an incorrect reference. If we look at page 27, yes, sorry, this is the bit that I need. If we look at under conclusions, 5 paragraphs down, there's a paragraph beginning, it was identified. So it says here, it was identified that the firefighters' override switches, the FOS on each floor in the lift lobbies, those were the little yellow key switches, may have been the weak point in the system in the event of a severe fire. The basic construction of these units left them vulnerable to heat damage, dust and water ingress. On the balance of probability, this allowed several of the firefighter override switch devices in the hottest parts of the fire to short circuits, causing the smoke dampers to behave unpredictably. And then they say damage from the fire to the smoke damper actuators would have also prevented them from operating correctly, which led to some smoke dampers being unable to either open or close in response to the unintended FOS inputs. Do you see that there?
Yes.
Now, do you agree with Rena that the construction of these firefighters' override switches left them vulnerable to heat damage, dust and water ingress?
It wouldn't have in the normal way of things, but it certainly did at Grenfell, but that was a unique event.
Did you ever consider whether that might be a weak point in the system?
I believe I specified them to be in the stairwell, but that's another story. I don't know why they're in the lobby. But I wouldn't have considered it to be a weak point in that way, because in a normal firefighting scenario borne out by the research and all the fire CFD modelling that's been done, you never got that fire intensity in a lobby during firefighting operations. It occurred at Grenfell. What can I say?
Okay. Yes, in fairness to you, I think your design does show these in the stair and not the lobby, and we'll be asking others why they ended up in the lobby. was unpredictable operation of the damper system in the event of fire and heat damage to the actuators or the firefighter override switches ever considered at the design stage?
The actuators themselves, as per the guidance again, the SA, 300 degrees C tested units. That's all. They're not there to be subject to whatever, 800 degrees or whatever it was in there. So it's what it is. It's a product again that is used.
Yes, I see. And just to complete what Rena's say, just going back to that page 27. Their conclusion was Rena's opinion, based on product information, the smoke damper actuators and the firefighters override switches were not designed to withstand exposure to the heat from an ongoing fire. As these units were exposed in the lift lobbies, it's likely that the system had not been designed to function reliably in a scenario where significant heat or fire were present in these areas. I think from what you've just said, you wouldn't disagree with that, but
no,
you said
an exceptional case because and the research was by BRE as well, not just the trade, and all the modelling that's been done. We've never experienced those kind of temperatures from a growing fire in a flat in the lobby area. It just does not occur. It has occurred here, and I dare say the trade will need to relook at itself.
Yes. Now, shafts and ductwork, just briefly, did you ever consider whether the shafts and the linings to those shafts might need testing to determine the leakage of the shafts?
No, I asked at the very first front end about the condition of the shafts, if they'd been inspected, etc. I was assured they had been looked at by other parties, and I was sent that couple of photographs to show me this constructional detail. And it's constructed from an A1 listed material. As long as it's, again, whoever's been inspecting the system would know whether they were suitable or not.
I see. So you were assured that others had looked at it and that's not something you considered, is that right?
In what way not considered? I considered that it should be considered to be looked at and made sure that it was okay. It was an old building. If all the blockwork was falling down, it would have been a problem. But I was assured it was found to be in reasonable order. Let's
just look at one clause in British Standard 12101 Part 6. This is RBK 45054, page 71. If we can look at clause 11.8.2.8, it says there, sheet metal ductwork shall be run within either the protected space or in protected shafts. Brickwork ducts may be used provided that such ducts are used solely for air distribution and the internal surface is rendered to limit air leakage. A sheet metal lining is used or it is shown that the leakage is satisfactory. Did you ever consider whether the shafts were consistent with that part of that British standard?
Yes, I asked the question and I was told they were in good order.
And who were you told that by?
That would have been coming from Max Fordham. And I did poke my head in a few of the sections that had been removed when I went to site. And it, to my eyes, but I'm not a building surveyor, it looked in good order. There was no sign of any cracking, no sign of any holes in the areas I looked. It seemed in very good order, actually, as though it had never been used.
I see. And the SCA guide also has a section, 2015 guide on builders' work shafts. It says the shafts should be constructed from non-combustible materials and be smooth internally. The size of the shaft should be in accordance with the design specification. It should maintain fire separation between corridors. It should have a maximum leakage rate of 3.8 meters cubed per hour per meters at 50 PA. Were you familiar with that part of the SCA guidance?
I was indeed.
Did you assess the existing shafts against that leakage rate in the SCA guide?
That isn't a requirement for me. That's a requirement for me to ask, and I ask the questions. Are they suitable? Whoever is responsible for the shaft would be responsible for checking that.
Did you ever document the response that you were provided with?
No, it is documented in the email that was sent to me.
I see. Now, in her phase 2 smoke control report, Dr. Lane explains that both the extraction ductwork and the dampers themselves needed to have a minimum fire resistance of 60 minutes based on the requirements of approved document B. Did you ever consider that when designing the smoke control system?
Yes, and the dampers did have a 60-minute fire resistance.
I see. And finally, the stack effect and the impact of positive pressure on smoke leakage. Are you familiar with the phenomenon of the stack effect as it applies to the movement of air in a high-rise building?
Yes.
Did you consider whether the vertical builders' shafts at Grenfell Tower amounted to tall shafts which might increase the impact of this stack effect?
Not in that direct sense, no. But I'm aware of the neutral pressure plane within a building, etc., and the effect of on systems, and I didn't consider it was a particular problem.
Did you ever consider whether the stack effect might drive smoke up the south shaft as the air in the shaft heated during the fire?
No, because there should have been a fan sucking out. That's only if there's a failure that we're talking about.
Did you actually consider the stack effect during your design, or is your opinion based on what you think subsequently?
My knowledge and understanding, it wouldn't have had a bearing on a mechanical system with the fans operating correctly.
Do you accept that the need to limit smoke spread as a result of this phenomenon makes it even more important that the dampers specified for the smoke control system met the smoke leakage limits for smoke control dampers?
I'm sure if they were available, I'd have put them in.
I see. And then finally, if we can go to PSB Technical Submission Revision 6, Section 3.4. This is at PSB 50214 at page 21. So here we can see that PSB also specified these BSB S series bypass dampers, and these were installed on level 2, and they related to the interaction between the environmental function of the system and its smoke control function. Do you recall that?
I do, yes.
Can you tell us why no performance requirement was set out in the technical submission by PSB for these BSC SC series dampers?
No, that's obviously an oversight.
Do you agree that because these level 2 bypass dampers were required to perform while the smoke extract fans were operating, they needed to meet the standards for smoke control dampers, i.e. BSEN 1366 Part 10 and BSEN 12101 Part 8?
They were smoke dampers. They weren't tested to that standard, but they were tested.
Okay. Mr. Chairman, I've come to the end of my prepared questions. Thank you very much for letting me have a little bit of additional time.
Well done, thank you. Now, we will lead the usual break at this stage. How long do you think you need? 10 minutes, or should we say 10 minutes?
I would hope that 10 minutes would be sufficient.
Right. We'll say 10 minutes.
Let you know if we need more.
You can let us know, exactly. Mr. Mahoney, as I mentioned to you a moment ago, at this point we have to have a short break.
Yes.
We will resume at 10 to 5 unless I get a message that more time is needed for dealing with potential questions, in which case we'll just have to hold you up a bit. But we hope it'll be 10 to 5, and at that stage we'll see whether there are any more questions for you. And as before, please don't talk to anyone about your evidence while you're away from the screen. All right?
Okay.
Good. Thank you very much. 10 to 5 then, please.
Okay, thank you.
Thank you. Well, we're ready to carry on, so I'm going to establish contact with Miss Grange first. Oh, well, no, I'm not. I'm going to establish contact with Mr. Mahoney first. Hello, Mr. Mahoney.
Hello. I can hear you fine.
Good. Here we are back again. We'll see if Miss Grange is there as well, and then we can find out whether there are more questions for you. Miss Grange, you there?
Yes, I'm here, and I can hear you clearly.
Hello, good. Thank you very much. Well, now, you can tell us, are there any more questions for Mr. Mahoney?
Yes, there are, just on 2 topics, but they should be quite short.
Yes, off you go then.
Thank you. Can we go back on the topic of dampers and the X-over testing document? Can we bring it back up? It's at GBL 705, and I want to look at page 42. If we look at the bottom of this page on performance criteria and test results, do you agree that under smoke leakage, it says smoke leakage, failure in accordance with the performance criterion of leakage is deemed to occur when leakage through the damper exceeds that amount, measures in the first 5 minutes of the test duration?
Yes.
And then in the last sentence, the specimen did not satisfy this criterion after the first 5 minutes of the test. Do you see that?
That's correct, yes, because it wasn't started in the open position.
Well,
that's the first 5 minutes.
You said before that it didn't actually fail this failure criterion because it wasn't tested for it, but it does look from this like it did actually fail that criterion. Do you agree?
Smoke leakage failure in cause of performance leakage deemed to occur when. Right. Okay. If it's a failure, it's a failure.
I see. If you were unable to find a certified smoke-controlled damper, can you explain why did you specify the Gilbert Series 54 damper, which we can see failed the smoke leakage requirement, rather than at least find a fire smoke damper, which had been shown to minimise smoke leakage?
A fire smoke damper would not be suitable for the application because it would shut on temperature. None of the smoke damper types that were available have been tested for the application which we will use it and could not be certified for that, and their damper motors would have clashed with the wall, so we couldn't put any of those in. The only thing that actually fitted, there were 2 vent types that actually fitted. One was an action air damper, and this particular unit, the action air damper had further problems in it. It reduced the area of opening. I said we already needed the maximum size we could get, and it also would have required an access door in the wall, which we're not allowed to put in. So the only thing that actually fitted was this particular unit.
I see. So your evidence is that you did look for either a smoke control damper or a fire smoke damper that fitted that space, and you couldn't find one. Is that correct?
That is correct. And I'm sure somewhere I wrote that to Matt Smith to say this is the only particular unit that will fit this application.
That was my next question. If none were available, why didn't you flag that for JS Wright, for the TMO, for building control, to enable them, if necessary, to think about risk mitigation given the potential for leakage because of using non-smoke rated dampers?
I did raise it with Matt Smith, as I say, early on, and said this was the only unit that was available, and the documentation was issued.
I see. So you raised it verbally. Did you ever raise it in writing?
I'm sure that was in writing. I'm sure in writing we say this is the only particular unit that's available that will fit this application.
I see. And in relation to Betterment, as you've been referring to it, what information did you have about the existing dampers to make any comparison with their performance and what you were putting in?
Only the photograph that was issued and what I physically saw when I went to site.
I see.
And these were virtually identical, the Gilberts.
Now, just my final short topic. Today, you've described Max Fordham's May 2014 analysis as this Betterment document, which you say was the basis of PSB's tender and what PSB was contracted to provide by way of design services.
Mm-hmm.
As I've already put to you, the document looks on its face like it's merely a comparative analysis, setting out proposals for the push-pull system proposed by Max Fordham at the concept design stage, following their discussions with Mr. McGregor. Do you agree with that?
Not the 13th of May one, no.
What document or express term of your contract with JS Wright do you say gave you a specific instruction to use this May 2014 analysis as your contractual specification?
That was the specification I issued with their inquiry.
Why, if that document was so central to what you say you were being asked to design, why don't you mention this in either of your two witness statements?
Because it wasn't anything to do with me. That was Max Fordham and building control. I was not party to any of that.
Okay. Mr. Chairman, thank you very much. I've come to the end, finally, to the end of my questions. I'd just like to thank Mr. Mahoney for attending today and assisting us with our investigations. We're very grateful.
Thank you very much, Ms. Grange. Well, Mr. Mahoney, it's been a longer day than perhaps you or we thought it might be, but I'm glad that we have been able to finish your evidence today. I can't see you on the screen, which is rather a shame.
I'm still here.
Yes, I thought you must be. It's just that I didn't have you on my screen. Thank you very much for making yourself available today. I think it's taken a little longer than than we first expected, but we have at least finished. And I think, speaking for all three of us, we found it very helpful to hear what you have to tell us on an interesting and rather intricate subject. So thank you very much indeed, and your evidence is really valuable. And now that's the end of it, and you're free to go and make a cup of tea or whatever it is you want to do now. Good. Thank you very much.
Thank you, and thank you for the opportunity to actually give you the information.
Good. Thank you very much. Well, we'll break at that point. We shall resume at 10 o'clock tomorrow morning when we have another witness. Thank you very much. 10 o'clock tomorrow.